Okay, so suppose you go to a company that pays, that's 2 cents for the first day, 4 cents for the second day, 8 cents for the third day, and so on. If the daily wage keeps doubling, what will your total income be for working for a month, 30 days? That's an interesting question, huh? It's actually a famous old riddle. I don't know if you've heard about it. The wise man did something great for the way it goes, the way I was originally told it. I think it's the old-fashioned version. The wise man did something good for the country. The king called him in and said, "I'm going to reward you. What do you want? You name it, up to half my kingdom." And the wise man said, "You know what? All I want is there was a checkerboard or chessboard, same thing, or sitting there, with all the, I think it's 8 by 8, isn't it 8 by 8, something like that? Squares, checkerboards, something like that, and checkerboard. And he said, I want you just to give me 1 grain of rice on the first square, and then 2 on the next, and then 4 on the next, and then 8 grains of rice, 16 grains of rice, 32 grains of rice, 64 grains of rice. I think I made too big of a table. Anyway, and then just keep doubling it all the way. And the king said, "That's it? That's all you want?" And the wise man said, "Yeah, if you'll agree to pay me that, that'll be good." And the king said, "Sure, all right." Well, if you figure that out, if you keep doubling, by the time you get down to the end, it's trillions and trillions and trillions. It's like a math trick. And so that's what we're going to see on this question. It's so small, doesn't it? 2 cents for a day, 4 cents for the second day, 8 cents for the third day. I mean, that's not very much wages, right? But if you keep doing that for 30 days, what's the total income? So that's what we're trying to figure out. So let's write it out. So 0.02 plus 0.04 plus 0.08 plus ... And we have 30 days or 30 terms, right? This is day 1, day 2, day 3, etc., all the way down to day 30, whatever that may be. Okay, so how we can do that? Well, that's a bunch of numbers added up. The question is that arithmetic or is that geometric? That's question number 1. Is this arithmetic? Is this an arithmetic sequence or geometric? Well, how do you get so remember the difference between those two? Let me go to the notes with you. Stuff is all in the notes. The exam 5 notes, right? Let me grab them for us. So here it is, down at the bottom. Get these right there. Okay, I'll bring them over for us. All right, so let me do one more page for the geometric. There. Okay, so here's arithmetic. And what's the deal with the arithmetic? Well, an arithmetic sequence adds or subtracts the same number from term to term, remember? And a geometric multiplies or divides the same number from term to term. So is this arithmetic or geometric? What's happening from number to number every time? Well, it's timesing by 2, as it says right here, keeps doubling. It's timesing by 2. So no, it's not arithmetic, it's geometric. It's multiplying by 2 every time. All right, so then let's use, now we want to know the sum of a geometric, don't we? Because it's geometric, it's multiplying by 2 every time, not adding the same number every time. It's geometric, and we're adding them up. We want the sum, total income. That means sum, add them all up. Total income for 30 days. We're trying to find the sum of a geometric sequence. Here it is, sum, geometric sequence, that formula right there. Right? There's our baby. That's our formula. So let's write that one down. That is S sub n, which is A1, 1 minus R to the n over 1 minus R. That's our formula. Okay, So what's the R? Well, coming down to the notes again, R is the ratio of second term over first term. R is 2. I don't know if you can see that already, but I'll do it formally. R is second term over first term. It is, here's the second term, 0.04 over the first term, 0.02, which is 2, which is the number being multiplied every time, of course. So it's 2. So R is 2. So S sub n, the sum. And A1 is the first term, which is 0.02. So we have 0.02 times 1 minus an R, which is 2 to the n, over 1 minus. And what's R? Again, 2. All right, so we have almost everything we need there to figure this out. So if we don't know n, or do we? 30. Remember what is n is in these formulas right here? N is the number of terms in the series. So n is 30. Because there's 30 terms, there's 30 days, right? In this situation, every one of these is a day. Every term is a day, and there's 30 days, there's 30 terms. So n is 30. Plug in. N is 30 right there. All right. So there we go. Now let's hit the buttons on the calculator. So let me see what happens. I'm getting a big number, crazy number. I'm getting 21474836.46. What is that? Look at that. 21,474,836.46. Look at that. It's amazing, huh? 2 cents the first day, 4 cents the second day, 8 cents the third day. Seems like nothing, but after 30 days, you keep adding, doubling that, add them all up, you're at $21.5 million. That is amazing, isn't it? That is the power of a geometric series. Doubling is powerful because the equation becomes what? Exponential. See? R to the n, that's exponential. The n is in the power zone. That's exponential growth, the power of exponential. That's why it surprises people. Somebody said, hey, look, I'm going to pay you 2 cents, and then 4, and then 8, do that for 30 days. You'd think, oh, yeah, no big deal. That's $21.5 million after 30 days. It's amazingly big. So there we